Hello again and welcome to our second set of prerequisite knowledge problems. I'm going to go through these, I think, more quickly, I hope, than the last set. Sometimes I think I talk too much, but let's give this one a try. Okay, we want the symbol of an ion that is composed of 47 protons, 62 neutrons, and 46 electrons. I hope you remember that we write symbols with the, oops, what did I just do? I do this too much. Use my pencil. We write symbols with the symbol. If there is a charge, it would go there. The mass, the atomic number, would go here if we chose to write it. And the mass number would appear here if we chose to write it. So go ahead and pause and see if you can write this symbol, and then restart. Okay, we're back. I am pretty confident that because the atomic number is 47, you could recognize that that is silver. With 62 neutrons, that gives it a mass number of 109. And because there is one more proton than electron, the charge is positive 1. We are going to focus primarily on this information most of the time. The mass number is of interest, certainly when we're converting from grams to moles, but commonly we will write this as simply silver plus 1. The atomic number can be assumed to be 47 because everybody has a periodic table. Okay, we focus more on the protons and electrons in this class. A few words about binary ionic compounds. Okay, these are made of, see if you can do the fill-ins here in that first line. Made of blank that are converted into, they are made of metals that are converted into cations, and they are made of nonmetals that are converted into anions. Okay? I'll remind you of page 67, where you can still find ion charges. And let's see if we can write some formulas. Pause the video, see if you can write those. Use page 67 if you need to, and then turn it back on. Okay, here we are. Sodium chloride is made of sodium plus 1 and chloride minus 1 ions for a formula of NaCl. Calcium oxide is made of calcium plus 2 ions and oxide minus 2 ions for a formula of CaO. Aluminum bromide is aluminum 3 plus and bromide 1 minus. Notice that I can sometimes write the charge as plus 2 or 2 plus, plus 3 or 3 plus. I honestly don't care which way you write that. You're going to see me doing it probably both ways. Your textbook will most likely do it with the number followed by the charge. Nonetheless, aluminum bromide would have a formula of AlBr3, and iron Roman numeral 2 nitride. Iron Roman numeral 2 is a plus 2 ion. Nitride is a minus 3 ion. And so this formula would have to be Fe3N2. All of these are written so that they have a net charge of 0. This next problem gives you a chance to practice determining molarity. Molarity, the definition is given in the first line. Generally, it's listed as molarity is moles of solute over liters of solution. Often this is shortened to molarity equals moles per liter, but it is also very important that you know solute and solution are part of that equation. There are times when if you disregard that, it's easy to make mistakes. So pause the video and see if you can determine the molarity of the solution. Okay, we're back. 30 grams of solute. This is magnesium nitrate. Magnesium nitrate is magnesium 2 plus and nitrate 1 minus, giving us a formula of MgNO3 2 for the compound. So in order to find the molarity, we are going to take 30 grams of MgNO3 2, divide by the molar mass of 148.3 grams per mole, and divide that by the solution volume, which is 0.3 liters. So we calculate a molarity of 0.674. Oops, and I have to round it to 0.67 due to significant figures. So glad I caught that. So we just found a molarity on the previous page of 0.67, oops, did it again, 0.67 molar magnesium nitrate. And we are asked to determine the concentration of each ion in the solution. Sometimes in a problem solving or in a lab, we're really not interested in both of the ions in a compound. We're worried about, we're going to focus on one or the other for a particular reason. So pulling one ion out of a compound and determining its concentration is pretty common. Okay, so pause the video and see if you can figure this one out. Okay, the ions in the solution are magnesium ions and nitrate ions. Okay, and because there is one magnesium ion for every one magnesium nitrate formula unit, the concentration of magnesium ions will be 0.67 molar because of the 1-to-1 ratio with the original compound. On the other hand, nitrate, there are 2 nitrate ions for every 1 magnesium nitrate formula unit. And so my value will be twice this, or 1.3 molar. Those are our 2 ion concentrations. This problem again is a stoichiometry, okay, and it does involve limiting reagent. So take a few minutes to work this out, pause the video, and then you can come back and see what I'm going to do with it. The first thing we're going to do is write the balanced equation for the reaction between these 2 species. This is a double replacement reaction. AgCl will form, and so will NaNO3. This is the product we're asked to determine how many grams will form, okay? And because I have amounts of both the silver nitrate and the sodium chloride, we have to find the limiting reagent. How do I find the moles of silver nitrate? Moles of silver nitrate is equal to the molarity, 0.20 molar, times the volume, 050 liters. And so my moles is 0.01 mole of silver nitrate. And I can do the same thing for sodium chloride. The molarity was originally 0.3. The volume is 0.040 liters. 0.3 times 0.04. That is 0.012 moles. And now, because these reagents react on a 1-to-1 ratio, it's pretty easy to determine the limiting reagent. It's whichever of these is smaller. Therefore, that is the limiting reagent. So in order to calculate the product, the silver chloride product, I take the 0.1 mole of silver nitrate. I multiply by a 1 mole AgCl for every 1 mole of silver nitrate ratio. And let's see, 109 plus 3.5. And multiply by the molar mass of 143.5 grams per mole of AgCl. And we end up with 1.4 grams of AgCl. And I've solved this problem with 2 significant figures. Thus, I have a 2 significant figure answer. Okay, good work. This wraps up the second of our lessons on prerequisite skills. Glad you worked through it with me.